So I'll just explain what we're doing. So nth roots of unity, what that means is you're finding the nth roots of 1. Okay, so we're asked to find the 5th roots of unity, so that means z to the 5 is 1. So 1 is a complex number in polar form is cis of 0, and I've just gone through and repeated the De Moivre's theorem process that we've just gone through. Okay, so you can see I get my answers here, and I've converted them to the appropriate domain given the constraint from minus pi to pi. Okay, so that's part A. We're pretty familiar with part A. Let's describe each part successively. Part B, letting W be the root with the smallest positive argument. Okay, so if these are my roots, W is the root with the smallest positive argument. It's going to be this one. Okay, this is the smallest argument, but it's not positive. Okay, so this is W. So if W is cis of 2 pi on 5, then W squared is just going to be cis of 2 pi on 5 times 2, which is cis of 4 pi on 5 to the 3. We're multiplying that by 3, 6 pi on 5, and then I'm changing the domains accordingly. W to the 5 is 10 pi on 5, which is 2 pi, which is cis of 0, which is also 1. Okay, so that's what part B is getting you to do. Part C, simplify this. Okay, so I've performed the expansion here. Here it is, and then that's what it simplifies to. 1 take W to the power of 5. Hence, they want you to show that this component equals 0. And it's a little bit sneaky what goes on here. Okay, now we know W to the 5 equals 1. Okay, we can see that here. So that means W to the 5 take away 1 is 0. Or so I should write it the other way. If I subtract W to the 5 from both sides, 1 take W to the 5. Okay, so we can see that from here. If I move the W to the 5 over, 1 take W to the 5 is 0. So that means this part here, when you expand this, it equals 0. Yeah? Which means we can now apply the null factor law. Either this component is 0, which is what it asks us to show, or this component is 0, and this contradicts our value of 0, of W. So, contradicts our value of W here. Alright, this would give you W is 1, which is a contradiction, so we reject that solution. So that means this is the solution to that, and so we've illustrated that component is 0. Is that okay? Alright, the last part then gets you to do is show that this is true, show that this equals 0 by vector addition. So if you draw these roots on the argument plane, they're going to look something like this. And vector addition, all we're doing when we're adding vectors is we've got vector 1, and then vector 2, we place the tail of vector 2 at the head of vector 1. Okay, so that's what I've done here. I've got, here's my 1, here's my W, W squared, W to the 3, W to the 4, and it takes you back to location 0. Alright, you won't be required to perform vector addition, but that's just what they're getting you to demonstrate, that when you add all the roots together, you end up back where you started. Alright, so F.2 is only a